Hello everyone, welcome back to another episode of Tantra's Mantra where we go behind and beyond the tech news headlines. I am Prakash Sangam, your host and founder of Tantra Analyst. One of the major accomplishments of 5G has been proving that millimeter wave bands are viable for cellular mobile networks. Convincing naysayers about millimeter waves has been as big a marketing challenge as it was an engineering one. There have been numerous tests and studies performed by many experts as well as novices to prove or disprove that millimeter wave bands do work. The most recent and probably the most comprehensive one was done by GSMA Intelligence, published a few days ago. It looked at typical deployment scenarios and use cases to conclusively prove that millimeter wave bands indeed work and can be very cost effective. Actually, I have extensively written about millimeter waves in general and specifically about this study. The biggest issue with millimeter wave bands is their small coverage footprint. That means you will need lots of sites to provide good coverage. And that creates challenges for operators both from cost as well as logistics perspective. But fortunately, there are solutions to address these challenges as well. And we have with us today Dave Cutter, CEO of Kumu Networks, to discuss these challenges and possible solutions. As a matter of fact, Kumu Networks is already building some of these solutions. Dave, welcome to the show.
Thanks, Prakash. Happy to be here.
Dave, I know that you are a serial entrepreneur, quite successful at that. Could you please give our audience a quick overview of your background as well as that of Kumu Networks?
Sure, absolutely. I've actually been doing the wireless startup thing my whole career. So Kumu is actually my third company. My first two companies had very successful exits and are part of the wireless ecosystem as we speak. In particular, my last company was called NextG Networks. We actually pioneered the concept of densification using small cells in urban areas, which is a topic that's become highly relevant to 5G. We grew that business for a number of years, and in 2012, sold it to Crown Castle in a $1 billion exit, which turned out to be a great deal for everybody, including Crown, who's done a fantastic job of growing that business the last 8 years or so. I got introduced to Kumu by some of the original investors, tier one VCs who had spun the technology out of Stanford University. And in short, Kumu has a deep technology that meaningfully improves the spectral efficiency of a wireless radio. It has application, really to any wireless radio. So Wi-Fi, defense applications, but notably, we've found an important market the last few years in wireless infrastructure, so 4G, 5G, and we'll talk a bit about that today. But I was very attracted to the Kumu story, and very proud to be part of commercializing that and being a big part of 5G as we move forward.
Excellent. And indeed, I mean, I worked on small cells for some time as well before I started my own venture. I mean, the densification we have been talking for a long time, and ultimately, the 5G millimeter wave, it's basically becoming kind of mainstream, right? So it's what the experience that you had would be very valuable, as operators start to deploy millimeter wave networks and densify the networks and such.
Yeah, no, absolutely. And as you think about what does 5G mean, for consumers, it probably means a new phone with a better camera. But I think people are expecting higher speeds. If you look on the network side, to some extent, it's the same challenge that carriers have always had. They need more spectrum and they need more sites and more places. And as you teed up, the millimeter wave spectrum on the one hand is beachfront property from a spectrum perspective. Instead of 80 megahertz, it's 800 megahertz of spectrum. But the rub is that the propagation of that spectrum is very limited. And so the challenge becomes how to cost effectively roll that out.
Exactly. And what are some of the things that operators are doing? Considering that the coverage footprint is a challenge to utilize millimeter wave in the best way.
Right. I mean, it's it's still early days, right? And so the operators are still, I mean, there's been public announcements about, I mean, Verizon, for example, I believe has millimeter wave service in about, I think it's 60 cities at this point, but it's very limited, right? It's in only in certain locations. Some carriers like AT&T have chosen to focus on venues. So they recently announced, for example, in Tampa, which is the site of the Super Bowl this year, they've done a number of venues using their 39 gigahertz spectrum. So that's great progress. And again, the question is, how to quickly expand that to larger scale deployments. And then, the way to do that cost effectively is the topic of some of the things we'll talk about today.
Perfect. As you mentioned, they have, spotty deployments in cities, maybe with very small coverage, and they have selected stadiums. I mean, they are looking at utilizing the lampposts and utility posts, small buildings and such to really bring this densification of network. But there are tons of challenges as well, right, in terms of densification.
Yeah. So you basically need three things, right, for a site. You need a place to put it, which that has its own challenges, although the right of way infrastructure, particularly lampposts and utility poles, are fairly ubiquitous, so that provides a good place to put things. That infrastructure also typically has electrical power. That's a solvable problem. The one piece of the site that's always the challenge is how to get the backhaul, right? How to get the signals from the site back to the carrier's core network and the internet and so forth. And so that's where the innovation really needs to be to make it cost effective.
Exactly. Looking at the cost structure of putting a site and managing it, backhaul is one of the key ingredients into especially the capex. Of course, there is a good amount of opex as well. And when you have this dense deployment, you have a site almost on each and every pole. The challenge becomes that much more, right? You have to bring in, say, fiber because all these are high capacity sites, right?
Yeah, so that's the other good point. I mean, we'll talk mostly about economics, but there is a time to market factor. I mean, just getting all the permits to actually build that much fiber in the first place, even if it was cost effective, is the challenge. And this term densification has been used for a while now, but for millimeter waves, because of the propagation, it really needs to be hyper dense, right? So I actually toured a small 5G network a few months ago, and I mean there were literally radios every, I think it was 5 or 6 utility poles. So that's a very dense deployment, and the fiber, especially in urban areas, having to trench the fiber lateral is tens of thousands of dollars plus ongoing operational costs. Actually, I know the carriers have learned from other activities like trying to bring fiber to the home, for example. That's just not an economical way to scale the network, which is why on multiple fronts there's been a search for alternatives to fiber backhaul.
Yeah, and I know you guys have been working on some of them, right?
Oh, absolutely. So yeah, so a little more about Kumu. So our core technology, it's a very high performance self interference canceller, and that's a little bit of a mouthful. But basically, what it means is that the radio can transmit and listen at the same time on the same frequency, and so that enables us to build something called a relay. And one of the things we've done in 4G is we have a commercial LTE full duplex relay that allows for fast and cost-effective deployments of small cells. Now in 4G, that's mainly done for coverage extension or in some cases for time to market. I think we've talked about for example these pop-up COVID hospitals. Is a good use case for where you need very fast deployment of backhaul. And so, part of the idea is to take that concept and apply it to 5G networks where it's going to, the need for that is on a much higher scale. Separately, and I know you've written about this, Prakash, there's standards activities that have gone into kind of formalizing, that concept in 5G. And they actually don't refer to it as a relay anymore. They refer to it as integrated access backhaul, or IAB.
Yeah, I mean, 3GPP is famous for coming up with these acronyms. Yeah, IAB, mouthful when you spell it out, but it kind of conveys what it does. Actually, as you mentioned, IABs were approved as part of 3GPP's release 16 that was finalized last year. I think in June it was. I mean, I'm a 3GPP member and attend all its meetings and such. 3GPP, it's more of a consensus-driven organization, but you have companies and people with totally divergent objectives and interests and such. But it was interesting to see IAB was one of the features in Release 16 which kind of had a universal appeal across the board. But also the simple IAB is it can do certain things, but it's not a holy grail as such, right?
That's right. But first of all, we're thrilled about the standardization. We've been doing relays in 4G, so we're excited to see that being more kind of formally approached in 5G. Before I answer your question, I mean, I think the first point is, why is everybody excited about IABs? Well, it's because effectively what an IAB does is it uses the wireless network itself to provide the backhaul, right? And so you don't need fiber to every site. You might have fiber going to one site, considered the donor site, and have that feed some number of these other sites wirelessly. And you can see right away that that has a dramatic impact on the economics and the time to market because you don't need fiber to every location. What was standardized in Release 16, though, and this is some of the limitations of that, are that the so-called access, which is between the site and the user, and the backhaul need to be independent of one another. And there's different ways to do that. You can either operate them on different pieces of spectrum, which carriers don't like to do that, first of all, and it also makes for very complex frequency planning if you want to have a multi-hop network, for example. Or you can kind of take turns between accessing and providing backhaul, and that lowers the efficiency, right? So instead of getting 100% efficiency, you get something much less than that, maybe 50 or 60%. And so that's where Kumu comes to the rescue. Quite simply, our technology allows both those backhaul and access links to operate simultaneously and on the same channel at the same time, giving you 100% efficiency and being able to hop as many times as you want.
Yeah, true. I've worked on repeaters long back and some of the relays as well. I think that was one of the major issues that either you have to have a dedicated spectrum for it, and then that means, as you mentioned, do a frequency planning. And every time you add another node, you basically have to look at this frequency plan and make sure you have to adjust it and such. So it was an ongoing concern, you feel, right? So you're saying with interference cancellation that you guys have, you could use same spectrum on both sides of the relays or IABs, both for access as well as traffic.
Yeah, absolutely. I mean, we already do that in our 4G product. We're well down the path of doing similar things in 5G, and there's a number of benefits to doing that, as you mentioned.
Is it standardized, or how does it work? If I say buy a IAB from vendor X, I can just install without knowing or bothering what is on the other side, on the backhaul side.
Yeah, so actually, this notion of a full duplex IEB where the both sides are on the same channel at the same time is actually one of the major topics of Release 17, which is in the works. Of course, we're not waiting for that standard. But the interesting thing is all of this is transparent, to the end user. So by making a call on a 5G network, that may be hopping over multiple Kumu IEBs at some point in the near future.
So basically, with IB is you take a box and hang on lamppost, you feel, right? For example, all you need is power to connect it to. Turn it on, it's ready to go, right?
Right. So there's no need to worry about backhaul, and because the links are on the same frequency, there's no need for frequency planning either. So it's a network that can optimize itself.
If you're looking at hyperdensification, so this could be the easiest way to achieve that, right? You don't have to plan too much in advance, and you don't have to work on bringing multiple fibers to all of these sites and such. That should save operators quite a lot in terms of cost as well as logistics, permits, timing, and such, isn't it?
It's a tremendous economic benefit in the short term. The dilemma that the carriers have is they want to get 5G millimeter wave into the hands of their customers, and there are phones that support it, and there's spectrum that supports it, but they need to get it in more places. Now, one of the interesting things about the IAB approach is that the carrier can still provide more fiber connections in the future, but then first of all, they're spreading that investment over time as more customers have 5G, more customers are using 5G. But the other thing is they can be smart about where they put those fibers, because they'll have good information about where their traffic is actually coming from, right? So it helps on multiple fronts.
Exactly. So I'm thinking, for example, if you take a crossroad with, like, say, four roads, you would put a donor at the center of the intersection, and you have IABs going along the roads, probably one IAB for a city block and such, right? That's kind of the deployment you are proposing to operators.
Yeah, so that's a good way to think of it. Kind of you think of kind of the Manhattan type model where you've got streets, urban canyons. The IABs actually help bend the millimeter wave signal around the corners, and yeah, maybe you start with four in each direction, or maybe even eight, and then by adding more fibers over time, you can scale that back. But at least the initial deployment is very fast.
Yeah. So what you're suggesting is basically, get rapid deployment with IABs, and then as and when traffic grows, you basically can change those IABs into actual fibered backward sites as and when needed, right? So basically, time to market advantage right away with IABs, and then option to change them to fiber backhauls when and as and when needed in the future.
Right. And so it kind of gives the carriers the best of both worlds, right? So they get coverage quickly, but then they also have a network architecture that they can evolve as their traffic grows.
Exactly. Yeah, one con of IAB or relay for that matter is it's basically distributing the capacity of a individual site through multiple IABs across large areas, right? They don't inherently bring their own capacity compared to an actual site, isn't it?
So that is true, but a fiber can actually carry quite a bit of backhauls. So I would say that the peak speeds wouldn't be meaningfully impacted by that architecture. I think the challenge is more what you're referring to is when the overall network gets loaded, right, with more customers. That's where some additional fiber donor points might be needed to relieve that capacity. But I think we're far from that. I mean, I think from a consumer side, the 5G phones are kind of in their early stage, right? So
Correct. And I mean, millimeter sites with so much of spectrum, close to like 800 megahertz, they have tons of capacity. So,
yeah, that's another good point. The carriers are used to dealing with much smaller slices of spectrum. So yeah, you would
correct.
think that what they have in the millimeter wave band would last for a while.
Yeah. So now coming to this interference cancellation or self interference cancellation, which I call SLIC. So tell me a little bit about that. How do you achieve that? I mean, interference cancellation or the SLIC has been in concept known for a very long time, right? But it was so hard to actually implement it in the right and most efficient way.
Yeah, it's an excellent question. And I like that term slick, by the way. Yeah, so conceptually, it's straightforward, right? If you can model the interference channel exactly, then you create the inverse of that and you subtract it out. And most people are familiar with the simple version of that, which is your noise canceling headsets that you wear watching Netflix or whatever. So what we've produced and commercialized it's that on steroids, right? So it's much higher bandwidths, much higher amounts of cancellation. The wireless environment is challenging in that it's a dynamic environment, so the channel is always changing, so we have to account for that. And the early years of the company, we invested quite a bit actually in all the building blocks that are needed to make that work, right? So we've developed our own chips, we have software, we built subsystems, and at this point, it's clear that the technology works and can be produced at scale. What we've really spent the last couple of years on is getting that into commercial products that can be consumed by the ecosystem. And we did that successfully in 4G. 5G is interesting because number one, first and foremost, the opportunity and the need is much higher, as we've been talking about. Second of all, the standards activity behind it is quite an enabler for everyone. And lastly, I'd like to mention that the other development that's happened in the industry is the Open RAN initiatives, which kind of touch many aspects of the network, but as it relates to cancellation and full duplex. So those Open RAN interfaces now provide kind of a natural insertion point for the cancellation technology, which, not to get into too many details, but that's been one of the challenges in the past is where do you put the canceller? How do you integrate with G node B or E node B? Where do you get the signals? And so that's actually now been greatly simplified, and it actually allows companies like Kumu and others, to work with a much wider set of radio vendors.
Yeah, that's an interesting point. Earlier, I mean, you only option for you guys was to go sell this to these large infrastructure providers, which have their own interest and probably they're working on their own technologies and such. But with Open RAN, the landscape is much different. You get many more opportunity to go sell and integrate your technology, right?
That's exactly the point. Yes.
Very well. So you said already have a 4G product with Slick. Where are we with the 5G versions of Slick?
We're testing prototypes as we speak. So there'll be some more announcements later this year.
Okay, perfect. So we are all well on the way because Verizon, AT&T, they said they were testing even last year and looking for deployments this year. So you think most of them, or at least a large portion of them, would be with interference cancellation, not using either double the spectrum or time duplex?
Well, there's a variety of approaches, but yes, I mean we believe the single frequency aspect of what we enable is going to be widely utilized. Yes, there are trials going on. I think some deployments will happen this year with wide scale deployments to follow. Right? There's a process to get into the networks, but in my world that's pretty quick. So things are coming soon.
Yeah. So you're looking at as customers, I mean, primarily operators, vendors. How is the supply chain and the value chain set up? We are in the mix of traditional deployments as well as a lot of this open and virtual RAN things coming up.
We do prototypes to trial with carriers and demonstrate capabilities, but our go to market model is to sell our technology and have it be integrated into the system vendors products.
I see. Okay. So you're pretty confident of 5G IABs, the called with Slick, getting onto the mainstream pretty soon then.
Absolutely, I couldn't be more excited about the not only our progress but the developments in the industry that have created that situation, and we're just happy to be a part of it.
That's great. I mean, there's so much of talk about millimeter wave. There's so much of questioning of whether they would work or not. But hopefully, we are beyond that stage now, and actual deployments happening, and there is this recognition of this need for hyperdensification, and there are tools available to achieve that. That's great news for the industry as such.
Yeah, and from my perspective, it'll be interesting to see kind of who gets out first and who's the most aggressive. I think this could be a situation where the first mover has a strong advantage, right, in terms of kind of brand recognition in 5G and providing that good quality service to their customers.
Excellent. I think we covered a lot of ground. Any final comments or thoughts? Did we miss anything?
I don't believe so, Prakash. It's always good to talk to someone like yourself who's been right in the middle of all this, and we're very excited about what Kumu can do for 5G, and looking forward to it.
Thank you. And I think that's the one beauty of 5G. In 4G, a lot of the action happened on the OTT side, whereas on the deployment side and such, it was in the same word, large infrastructure companies trying to provide the infrastructure. But 5G with these architectures with Open RAN coming in, there a lot of scope for innovators like Kumu to play a key role in making a lot of things happen.
Yeah, I mean, the ability to deploy things quickly, cost effectively, in a hyper dense way is critical, and we're right in the middle of solving that problem.
Very good, and best of luck with your endeavors to bring that to fruition. I'd like to thank Dave very much for all the information and insights he's provided. It's a lot of exciting stuff. Dave, really appreciate you coming on to Tantra's Mantra. Hope to see you back soon on the show.
Absolutely, Prakash. Thank you.
All right, folks, that's it for now. Hope it was informative and you found it to be useful. If you did, please hit that subscribe button down there. I'll be back soon with another episode, putting light on another interesting tech subject. Bye bye for now.